This video is going to be the first in a series on general chemistry, and this is probably going to be a series that's suitable for high school chemistry, AP chemistry, or your first year introductory course to chemistry in college. So we're going to start off by talking about acids and bases. And for this video, we're going to go through the different definitions of acids and bases. I'm not going to really go through the history because that's something you'll probably get in your class. But basically, there were different chemists throughout the period in which definitions for acids and bases were being developed, and they all looked at acids and bases in different terms, but the motivation is the same in each case. It's generally to describe how different chemical species react. Okay, starting off with Arrhenius acids and bases. An Arrhenius acid is defined as a substance that ionizes in water and produces hydrogen ions, or H plus ions. So we have the example of hydrochloric acid dissociating into H plus and Cl minus ions. An Arrhenius base can be defined as a substance that ionizes in water and produces hydroxide ions, so OH minus ions. And we have the example of a reaction of sodium hydroxide, NaOH, dissociating in solution, so putting some NaOH into water is going to give you Na plus, so sodium cations, and hydroxide anions, OH minus. And we have another category of acids and bases, which is Bronsted-Lowry. So a Bronsted-Lowry acid is defined as a substance that is capable of donating a proton, which is the same as donating an H plus ion, and a Bronsted-Lowry base is defined as a substance that is capable of accepting a proton. So now we have the example of a reaction of acetic acid being placed in water. So we have HC2H3O2 plus H2O, and it's reversible. That's why I have the arrows going forwards and backwards, and it's reversible to C2H3O2 minus plus H3O plus. In the Bronsted-Lowry definition, H2C2H3O2 and H3O plus are acids, and C2H3O2 minus and H2O are bases. So we're already seeing here the same type of reaction, but different definition. And to be clear here, we're taking some solid acid and we're putting it into water, and it's dissociating into ions. All right, and we have another example. We have an additional example for Bronsted-Lowry acids and bases. So we have NH3, ammonia, plus water, and that's a reversible reaction, so the arrows are going forwards and backwards. And the products are NH4 plus, so an ammonium ion, plus hydroxide ion, OH minus. In this case, NH3 and OH minus are bases, and then we have H2O and NH4 plus are acids. In both the examples, the species with the H plus ion is going to be the acid, and the same species without the H plus ion is a base. The two species are referred to as a conjugate pair. So the one with the H plus and the one without, they're a conjugate pair. So we have different conjugate pairs from these examples. We have HC2H3O2 and C2H3O2 minus. Then we got NH4 plus and NH3, H3O plus and H2O. And then we got H2O and OH minus. So we got acetic acid, ammonia, and water. And then the conjugate pair. So we have the conjugate base and the conjugate acid. And we're looking at which one has the H plus ion. Okay, and now we have the most broad definition, which is the Lewis definition. And a Lewis base is defined as an electron pair donor, and an acid is defined as an electron pair acceptor. So we've seen that all the definitions are going to be different. So Bronsted-Lowry and Arrhenius, they are defined in certain terms, and then Lewis is defined in terms of electron pairs. So in this definition, we note that we include Bronsted-Lowry bases and Lewis bases as the same. And the same goes for the Bronsted-Lowry and Lewis acids. And this will probably make more sense with an example. So for the example, we have NH3 plus BCl3. So you can see there's an electron pair, a lone pair of electrons on ammonia, NH3. And the reaction of these two chemical species is going to give us H3NBCl3. In this example, NH3 is the Lewis base, donating its electron pair, and BCl3 is the Lewis acid, accepting the electron pair. So you can see the Lewis definition is the most broad because it centers around electron pairs.